All right, last one. You'll notice this is the almost identical same problem, except instead of saying equals 3, it says equals 1/3. Well, that is going to change how we do this just a little bit, because now I have two denominators. So I'm going to multiply both my things by both denominators. Now, again, that's not going to change much, but it is a slight difference. And it's going to give us a chance to see how that difference plays out. So now, when I multiply this times this, the 3x plus 1's reduce to 1, and I'm left with 3 times 3x minus 2. So I'm left with more than one thing. It's not just that one thing anymore, because two things were there. I canceled. All right, so then when I multiply this by this, the 3's reduced to 1, and I'm just left with 3x plus 1. Now, technically it's times 1, but obviously if you're multiplying by 1, you're not really multiplying by anything. It's the identity property, it stays the same, so you don't need to do much. So now we're going to distribute again. 9x minus 6 equals 3x plus 1. So again, we're going to make a choice. I'm going to choose to subtract 3x from both sides. So I get 6x minus 6 equals 1. I'm going to choose to add 6 to both sides. So I'm going to get 6x equals 7 again. And then lastly, I'm going to divide both sides by 6. And for what seems like the 40th time, I'm not going to type it in a calculator. I'm not going to try to get some fraction that I have to estimate. I'm just going to leave it as as a decimal that I have to estimate. I'm going to leave it as the fraction 7/6. So let's see. Hey, I was 4 for 4. Hopefully that really helped. This is one of the big things in Algebra 1. It really plays a big role in Algebra 2. So hopefully we can make sure and understand this.